Okay, today we're going to talk about hyperbolas, which is our next conic section that we'll be discussing. So before you continue on with the video, I want to make sure you have the note sheet printed off from today's assignment so you can copy this down. If you'd like to pause the video, you can go ahead and pause it and get the sketches down, and so you can have your full attention as to when I'm describing everything. Okay, so the hyperbola on the left is a hyperbola with a horizontal transverse axis. So the axis and the hyperbolas we're talking about today are all centered at the origin. And so that transverse axis is the axis that goes through the origin. And I don't want to say it's perpendicular, but it's kind of perpendicular to the arms of the hyperbola. I'm using that term perpendicular loosely, but it kind of has that appearance. So your transverse axis is this piece right here in black right there. That's your transverse axis, and it does continue on either side, but that's the most important part of it. In the hyperbola on the right here, same idea. Your transverse axis goes this way and continues on past the arms of the hyperbola. You'll also see that you have a vertex where each of the arms of the hyperbola intercept that transverse axis, and then you have your foci, which are also located along that transverse axis. Now, when you're looking at the equations, notice how they are slightly different. The equation here on the left, your x squared term is positive. The equation on the right here, your y squared term is the positive one. Now, notice that's really important. The equation looks similar to the equation for the ellipse, but it's not because of that negative. And that negative in there tells you which type of hyperbola you have. If the x squared term is positive, you have a horizontal hyperbola. I call it horizontal because the transverse axis is horizontal. If the y squared term is positive, you have a vertical hyperbola because that transverse axis is vertical. Okay. Now, what's also different is the a squared and the b squared. You'll notice that the a squared is always under the positive value, whether the x is positive or the y is positive. But there's no stipulation as to whether or not a squared has to be bigger than b squared, like it was with the ellipse. Okay, so that's the difference there. The only way you can tell what type of hyperbola you have is which one is positive and which one is negative. And your a squared is always under the positive one because a is always along that transverse axis. Okay, also one other thing I want to talk about is finding the foci. You're going to use c squared equals a squared plus b squared. Just like Pythagorean theorem, c squared equals a squared plus b squared. So let's do a couple of examples. The first one here says to find the equation of the hyperbola, and all they gave you were the foci and the vertices. The foci are at 7, 0 and at negative 7, 0, so they're here and here, and the vertices are here and here. So it's easy to tell that your transverse axis is horizontal because your foci and vertices are always on that transverse axis. And because of that, I know that I have the form x squared over a squared minus y squared over b squared is equal to 1. Our center is at 0, 0. Remember, a is the distance from our center to our vertex, so a here is going to be 6, and our c value is the distance from our center to our foci, so that c value is 7. Now I'm going to explain to you what the b value is and how we use that in the next slide, but for now all we're going to do to find that b squared is to use c squared equals a squared plus b squared. So c squared here is 49, a squared is 36, and I'll get b squared. So I end up getting b squared is 13. Now notice I don't actually need to solve for b because I just need b squared to write the equation. So I have x squared over 36 minus y squared over 13 is equal to 1. In the problem on the right here, this is just kind of the reverse, whereas the foci and the vertices are along the along the y-axis, so the transverse axis is vertical. So I know that my equation is y squared over a squared minus x squared over b squared is equal to 1. I know that my a value is 2 and that my c value is 3. So a squared plus b squared is equal to c squared. 4 plus b squared is equal to 9, so b squared comes out to be 5. And so when I plug that in, I have y squared over 4 minus x squared over 5 is equal to 1. And you see here that the b squared is in fact larger than the a squared. It doesn't matter which one is bigger. It just matters that the a squared is under the positive 1, whether it's y squared or x squared. Okay, so let's talk about asymptotes. When we graph hyperbolas, the big thing that we need is our asymptotes, which is a line the graph approaches but never touches. And what they do for us is they allow us to figure out where to put our hyperbola. Once you know your vertices, it's hard to figure out. Does your hyperbola, is it more shallow like this, or is it more pronounced like that? And that's where the asymptotes are going to help us out. So let me show you what I mean here. Let's do an example equation. Let's say I'm doing x squared over 4 minus y squared over 9 is equal to 1. So I know that my a value is 2, and I know that my b value is 3. Okay, I also know that my vertices, there's my a value, my center here is at the origin, so I know that those are my vertices right there. Now, here's where the b value comes into play. You are always going to count from your center along the axis that is perpendicular to your transverse axis. Here's my transverse axis. So perpendicular to that would be my y-axis. And so I'm going to go 3 from my center in either direction along that other axis there. What that allows is for us to create a box or a rectangle. And once we have that rectangle, if I draw in the diagonals of that rectangle, those then create my asymptotes. Whoops, I did that a little sloppy just because I'm trying to rush. Those create my asymptotes, which now when I graph, I know my graph will approach those but never actually touch it. I don't need you to plot any specific points. I just need a sketch of your hyperbola. And so that's what your sketch would look like. And those asymptotes tell you how wide basically the arms of your hyperbola are. Okay. Now, the equation of that asymptote, remember it's a line, so I need a slope. Your slope, this is how the box helps you. Your slope, go from the center to the corner of your box. You're going up 3 and over 2. So the slope is 3/2 x. My y-intercept is 0 because I'm going through the center. So that is the equation of my asymptote. My other one is down 3 and over 2. So I can write the equations of my asymptotes as y is equal to plus or minus 3/2 x. In general terms, we say y is equal to plus or minus b over a times x. Okay, over here it's the same exact idea, you're just flipping those values. So you have y is equal to plus or minus a over b, x would give you your your other asymptotes. So for example, if I had y squared over 36 minus x squared over 49 is equal to 1. I know that my a value is 6, my b value is 7, so my asymptotes are plus or minus 6/7 x. Your box would be, and I'm sorry I'm rushing, I just want to make sure I get this all in. Your box would be here, and my box is a little sloppy, but there would be your box. You would draw in your asymptotes this way and this way, and your graph itself, because it's a vertical one, it would end up going like this. And then down here would go like that. Okay, so the last thing really quickly, I'm going to skip over this first example. I just want to look at the second one just because of the format in that it's written. You need to get it into the standard form before you can graph it. So to do that, what we need to do is to get the right side of the equation equal to 1. And how to do that is we're just going to divide everything by that value. So I'm going to divide everything by 36. So that would give me y squared over 4 minus x squared over 9 is equal to 1. And now that I have it in the proper form, y squared is positive, so it's a vertical hyperbola. I know that a squared is 4, so a is 2. I know that b squared is 9, so b is 3. And you can finish it out from there. Okay, so these are your equations for your asymptotes depending on what type of graph you have. That's how you would go about graphing them. Hopefully those notes help when you're doing the assignment. Then the next lesson we'll be talking about what happens when you shift your hyperbola and your center is no longer at the origin and it shifts to a different point. Thanks folks, have a great day. Take care. Bye-bye.